The discussion of your flight instruments, also known as your six-pack, is easiest to understand if we break them into two groups. One group being the pitot instruments, and the other one being your gyro instruments. First, we're going to take a look at your pitot system. The instruments that work off your pitot system are your airspeed indicator, your altimeter, and your vertical speed indicator. Let's look and see how the airspeed indicator works first. The airspeed indicator works off your pitot tube and the static port. The pitot tube is basically just an opening that allows ram air pressure as you travel through the air. It allows ram air pressure to come in through this tube and inflate a little wafer. They call them airnoid wafers. And the faster you go, the more air that inflates inside of the little airnoid wafer, the faster your airspeed indicator indicates through different gears and linkages through the connection. But as you climb higher, then the air that comes into your pitot tube is thinner and thinner and thinner. So in order to get a more accurate reading on the airspeed indicator, we need this little wafer to be able to expand against the outside atmospheric pressure that you're flying through. So for example, if you're flying at 6,500 feet, you have thin air coming into the into your pitot tube. So I need to compare the ram air coming into the pitot tube with the thinner air that I'm actually flying through. So the rest of your instrument casing is vented to your static port. Your static port is placed usually on either side or both, either sides of just behind your engine cowling. Sometimes it's located back closer behind the tail. But they strategically place this static port, this tiny little opening, so that the airflow off of your propeller doesn't disrupt the air around the static port. So because the air is static, meaning that the air doesn't really move much around where the static port is placed, they call it a static port. So your airspeed indicator works by ram air coming into your pitot tube, inflating the wafer against the outside atmospheric pressure that is read or measured via your static port. Now, the examiners like to ask you what happens if your pitot tube became blocked. How does it affect your airspeed indicator? And frankly, you would like to know this as well. Let's say, for example, that you flew and a bug, a little bumblebee here, a little bumblebee got lodged into your ram air hole of your pitot tube. So this no longer allows the air to come in and inflate the wafer. So what happens to the air in the wafer? Well, you have a drain hole. The purpose of the drain hole is normally, if you fly through rain, the rain can exit the drain hole instead of filling your instrument with water. So since I have a drain hole here, the air that was trapped in your wafer now would just simply leak out of the drain hole and your airspeed indicator would go to 0. But what would happen if another bee jammed that first bee in and blocked the drain hole also? Now, how would your instrument work? Since you have air that is now trapped into this wafer, if you increased your airspeed indicator would not change because there's no additional air coming in here. Or if you slow down, your airspeed wouldn't change. So faster, slower, there would be no change. But what happens if you climbed higher? If you climbed higher, and this is trapped air, and you climb higher to where air pressure becomes less and less, it allows this wafer to expand because there's less pressure around it. So if you initiated a climb with a complete blocked pitot tube, your airspeed indicator would actually show an increase because the wafer is allowed to expand against the less pressure. It allows your airspeed to show an increase, which would be backwards from what normally happens when you initiate a climb. Normally when we initiate a climb, your airspeed depletes off. So this would work backwards from what you're normally used to seeing. Or if you initiated a descent and you flew down into thicker and thicker outside atmospheric pressure, the pressure would cause a constriction on your wafer and it would cause your airspeed to appear to slow down. And normally when we descend, your airspeed speeds up because you have gravity pulling the aircraft down faster. So it would appear that your airspeed would slow down if you descended. Now your altimeter works basically just like I just described a block pitot tube with your airspeed indicator. Because on your altimeter, there is a wafer in there. It is basically a closed capsule. And it's just relying on the change in atmospheric pressure that enters and exits through your static port to allow that wafer to expand and contract. So if we climb higher and the outside atmospheric pressure becomes thinner and thinner, it allows this wafer to expand and show an increase in our altitude. If we descend, the air becomes thinner and thinner. The air becomes thicker and thicker. It compresses the wafer, and it would show that our altimeter is decreasing. Now, the vertical speed indicator works just like the altimeter, but there's one difference. Through the port that the air comes and goes as we climb and descend, there is what they call a calibrated leak or a restrictor. And because this is here, it would be the difference of you trying to breathe through a straw or you trying to breathe through a coffee stir. You couldn't breathe as quickly. And this restrictor, or called a calibrated leak, it slows the passage of air down and therefore ends up showing a rate of climb or rate of descent. So if you had initiated a climb, your altimeter will change instantaneously, but your vertical speed indicator will only change at the rate that you are changing. So the vertical speed indicator has a pretty decent lag in it. You cannot rely on your vertical speed indicator to show if you're climbing or descending. But after you're climbing or after you're descending, then it becomes accurate. So just remember that your vertical speed indicator has a pretty decent lag in it. So that's basically how your airspeed, your altimeter, and the vertical speed indicator work off of your pitot tube and your static port.